Good morning, dear students. Today I am going to explain the remaining questions of chapter 11, that is midpoint theorem. In the treatment class, I have started this chapter and I have explained the properties. First question is over in treatment class. I am going to begin from the second question. In second question, you have to prove that the triangle formed by joining the pairs the midpoint of the sides of triangle are congruent to each other. If we have a triangle ABC and D and E are the midpoints of side AB and AC, then you have to prove that, and F is also the midpoint of BC, then you have to prove that the triangle which is formed here is congruent with the other triangles. As we can see here, we have 1, 2, 3, 4 triangles. Okay. If D and E are midpoint, so by midpoint theorem, we can say that DE is half of BC. DE is half of BC and BF and FC is also half of BC. So we can write that BF is equals to FC is equals to D is equals to half of BC. All the three sides are half of BC. When we see the triangle, when we see this side as a base, D and F are the midpoints, so we can say that DF is half of AC. E is the midpoint, so EC is also half of AC and AE is also half of AC. Okay. When we see this AB as a base, then these are the 2 points, midpoints. We can say that EF is half of AB, AD is also half of AB, DB is also half of AB. Okay. When we write this type, we write the values of the sides, then we can see that this DE, FC and BF, they are equal. This AE equals EC equals DF, AD equals DB equals EF. Okay. You have to prove the triangles congruent. So you take any two triangles. Let us take ADE. In triangle ADE and triangle DEF, AD is equals to EF is equals to reason half of AB by midpoint theorem. AE is equals to DF is equals to half of AC by midpoint theorem, the second value. DE is equals to DE, reason common. These all are the three sides. So by SSS, triangle ADE congruent triangle DEF. Similarly, the other triangles are also congruent. You can write them congruent. So I hope you can solve this. Next we have third is also same as this question. Now we have question number 4. In fourth question, it is given that the diagonal AC and BD of a parallelogram. We have a parallelogram ABCD. Intersect at O. if P is the midpoint of AD, P is the midpoint of AD, then prove that OP parallel AB. If it is the midpoint, we know that diagonal bisect each other, so we can say that O is the midpoint of DB. O is the midpoint of DB. P is the midpoint of AD. So by midpoint theorem, OP is half of AB and OP parallel AB. Is it clear? And as we know that the opposite side of the parallelogram are equal, so we can write that OP is equals to half of, in place of AB we can write CD. It is proved. The second part is proved. Now I am going to explain the fifth question. In fifth question we have this type of figure. A, B, C, D. SRPQ. This type of figure is given, and in first part we have to prove that SR parallel AC and SR is half of AC. These PQRS are the midpoints. So when we take triangle, in triangle ACD, SR are the midpoint, so SR is half of AC, reason by midpoint theorem. If it is half, then we can write SR is parallel to AC, reason same, by midpoint theorem. The second thing is we have to prove that PQ is equals to SR. How can we prove? In this triangle we have written that SR is half of AC. Now in triangle ABC, these are the midpoint, so PQ is also half of AC. This is the first equation and this is the second equation. Right side are equal, so left side will be equal. SR is equals to PQ. It is proved. The second part is proved. Now join this DB. When this DB is joined, then we can write that RQ is half of DB by midpoint theorem, and here PS is half of DB. Right side are equal, so left side are also equal. RQ is equals to PS. Opposite sides are equal, so we can say that PQRS is a parallelogram. The last part is also proved. So I hope you can solve the questions up to 10. You solve the question up to 10, and if you have any queries, then it will be discussed in the next live class. Till then, try to solve up to 10. Okay, take care, bye bye.